Hello, ETHDenver. My name is Tomer. I'm going to talk about static analysis in the era of AI agents. So this is me. I'm CTO at AuditWare, so we're an auditing firm. Been a security engineer for the past decade or so. Like doing open source work, auditing smart contracts. Yeah, so we do a couple of interesting stuff in AuditWare. A part of those is our open source suite. So as you can see on the screen, we got a bunch of cool stuff going on. We got the W3OS, which is a Web3 operational security standard. We got Radar that does static analysis for smart contracts, Rust, Solidity. We got multisig monitor that does safe wallet multisig analysis, monitoring suspicious transactions, and all that. So as I've said, we've been doing audits for quite a while now, and we also have Sentry, which is a platform for the more larger projects and protocols to protect them continuously after they're on board. And on Sentry, we also utilize our open source work as APIs to basically get the full suite going. Okay, so I'm here today to talk to you about specifically Radar from the open source tooling that we just discussed about. And I like to start with demos. I know it's like a bit unconventional. This is Radar from the normal user perspective aspect, at least. So it is a CLI tool. You can run it from wherever. You just run it across like any smart contract you want. It does like extraction of AST. It supports Rust, Solidity, and a bunch of frameworks. And it has a cool template-based design that fits perfectly to how AI is used to lock down secure research perspectives in our age. So you got this on the screen, like Python logic that's locking down their security researcher's perspective, and you can run it and reuse it. So we're going to talk about that. Okay. So yeah, so who uses security tooling? Or specifically static analysis, where AI basically is doing everything today. It's like 2026. So we know that everyone can just like run a Claude or Copilot, a security review style audit, which is very concerning, especially from a security perspective. And we have like, I don't know if you like to listen to Stack Overflow, because I'm not sure anyone uses Stack Overflow anymore. But if you look to statistic, it's like constantly an uptrend of developers using AI without like fully blind, let's say, to generate tests, generate security tests, all of that. So if a developer, especially smart contracts ones, used to know exactly what's going on in their code and spend and write every line, it's no longer the case. Yeah, and specifically more concerning is the fact that also security firms, so you already did like your own vibe auditing as a protocol developer, then you go to hire a security professional, and you don't know if that professional too is using AI to perform the audits. So that's just like the market status right now. There's a lot of stuff to battle it. Specifically about Radar, first, like the value proposition, especially because static analysis is sort of underpowered against AI-based checks, is basically we say this: instead of using AI to do code audits or code checks or whatever you call it, find bugs in my contract, we say there's another step in the middle using Radar, is that you tell the AI to run Radar templates, and then you get sort of like a deterministic result that you can reuse, share with other security researchers. And the point here is that you don't lose value, and you don't lose more tokens practically, because if we are talking about running on-chain, which we'll talk about it, what Radar is designed to, then we're talking about like constantly reuse of the same queries inefficiently, and people don't have that funds to spend on tokens as much. So what we do is when we save it like as a Python template, and we let it like on a small scale VPS to run using Radar, we can get a lot more value and checks in the same amount of funds, basically. So how are we doing this? Let me jump over here. We've had a lot of design considerations and debates internally about what exactly is it for, because a normal static analysis, if we take like Slider or not even Web3, but static analysis tooling in general, it's meant to be used like by a developer or auditor across one code base. And that's it, take the results and go. We're not in that approach. We built this entire thing to not be first like as a convenient thing for end user, but first be convenient for apps that want to integrate this as a continuous monitoring, scanning service. Same goes for like app developers and like for security hunters that wants to look at the same vulnerability across a large amount of contracts. So this is the entire idea and design behind Radar. We found it to be especially starting to get like worth the complexity of it when you have like more than 200 contracts you want to scan at the same period of time. So that's where like it gets exponentially just like quicker and more efficient. We chose a template-based approach inspired on Nuclei. So if there's like Web 2 in the crowd, Web 2 professionals, then everyone knows this. It's like the best applicative scanner open source project there is, in my opinion. And it has like a huge success by the fact that it created easy templates to be reused. So instead of writing the entire program, the developers do the core logic, and then the researchers don't have to be necessarily aware of how the engine runs, just like the template language. So that is what we wanted to achieve, with a small caveat, because it gets pretty crazy. What Nuclei did is they had a YAML language, which is very simple. It's not like a programming language. And researchers got crazy with it, because as time grew, they tried to do like inner for loops, nested for loops. It just got crazy, and this is like not a readable template in any way. So we chose Python instead, and that is also like a debate, because I know that a lot of folks would have rather seen Rust as the language, because that's like how it goes right now, and I personally love Rust. We found that specifically for AI-generated templates, AI does better just generating Python. For example, you can give it like, what is the best language to use to build this project? It will say, wow, definitely Rust because ABC. And then you say, OK, implement it, and it starts off Python. So there's been research on that, very interesting. Also, it's like readable to humans, because I love Rust again, not readable. Which brings us to how are we performing the static analysis? Well, OK, from the picture, then regex is not really relevant, just like for obvious reasons. The main debate was between LLM IR to ASTs. So if you're not familiar, breaking down AST means just like taking down a contract and tokenizing it to a tree. It looks like a JSON structure, and then it's very easy to understand the code rather than regex or so on. LLVM-IR also is queryable in a similar manner, just felt, again, not in the readable manner, more as AST. And we will only be successful in this project if researchers would have fun writing templates. So that's like a point on the AST. And to do that from Rust-based contracts, which is the origin of Radar, was like a Rust-based static analysis tool, is we just like used Rust-C native library to generate AST or to compile Rust, and just did like a small trick to wrap it around to be importable like as a Python module. So that's like that opened up to immediately to be able to run like native Rust, Encore Rust, Stylus Rust, a lot of static analysis out the box, all plugged into the same engine. Recently also we added Solidity to it, so that's very cool. Yeah. And this is like a template. So we've seen the Nuclei template before. It's not that different. The template itself is YAML. And then you have this rule in the middle. The rule just says, iterate. We like get the AST for you. We inject it into this tiny rule here. We iterate the nodes for you, a simple for loop, accept, try conditions. And you just whatever you want to do to define or like basically to describe your bug pattern. You just Python it, and this works amazing with AI. On top of that, we added like utility functions. So AST, even if it sounds like simple, just like rules against an AST, it's still very complex and not necessarily mapped to how our human brains work. So we created a full list for every time we wanted to write our own detection for bugs we found. We thought, okay, it will be cool if given an AST node, we can find all its parent, et cetera, and basically it creates sort of like a mini language that you can just chain call to find stuff in AST quickly. Again, good for humans, good for AI. And there's the security concern aspect, because basically you're running GitHub templates that run Python rule on your device, or like on a Docker, but it's still on your device. So what we did is we like stripped out anything that we managed to come up with that's dangerous about Python, because all we do is just like iterate AST and don't do network calls, no like subprocess be open, and we did like a tiny whitelist. Then before we execute the Python itself, we do this check that no one is doing anything suspicious, again with AST parsing, but that's different AST, but you get the point. So yeah, that's like mostly the logic behind what we did. So if we take it back to like how we imagine you working with it, and like how we imagine you utilizing Radar for your purposes. So you could be like a security auditor or just anyone interested in doing like any sort of mass vulnerability detection across many contracts out there. So we don't take care of the contract retrieval part yet, but you can be creative with that. What we say is like that. Let's say you're a security researcher, and you find like a bug, or you're doing like your audits, and you do it like whatever. At some point, you find a certain detection that you say, okay, this happened here. This is very complex. I can't like write like a simple rule for it. But I know for sure all the contracts are going to fall for that specific pattern. So what you're going to do is you're going to have AI, and of course with human in the loop, generate a Radar template that defines exactly what you want to say. But the cool part here is that you define it once, you test it once, you share it with your peers, you review it, and that's it. It's not like sometimes true, sometimes not. It's like scientific, deterministic result. It's not like a cloud code security review. Every time we'll give you a different answer. You can't trust it. This is something you generate with yourself using AI, end up with a tiny Python script that AI is optimized to work against, and you can just spray it practically. So scraping your targets, again, that's also a very common thing, especially in the Web 2 world and the nuclear example from before. Then we had like React to Shell 2 months back. So like 3 hours after React to Shell dropped, there was a nuclearly signed template by a security researcher. The community reviewed it, and people who wanted to see if they're vulnerable, CISOs, CTOs, could run it. And they could run it sort of safely, because there was not much code to see, okay, is this tiny script doing something bad and trying to like exploit the fact that I'm vulnerable and like I'm in a rush and introduce malware. So for example, like to extend on that, like on the React to Shell example, we've seen a lot of Python scripts that like equivalent to what I'm talking here, that says, quick, protect yourself, check if you're vulnerable. What in fact it did was try to get like API keys from developers not reading the code and running Python in a rush with 2 stars. This is why we're trying to ecosystem that whole manner. So going back to my original point is we want the same thing to happen for Web3. And when there's like a new bug pattern coming out, we want researchers to do this similar contribution. So we will be able to secure contracts at a scale. Radar is like already like ready for that. The only thing we need is more contributors and more templates. We are like in around 30 right now. We aim for like the thousands. And yeah, so for like personal researcher incentives alone, you don't have to share these templates. You're free to spin up your own VPS, run Radar on it. It's like one command. And you can just run your own templates and only contribute the one that you want. And That's the whole process. So you can report it, get your bounty at scale, not like one project at a time. When you're done and when like the pattern is exhausted and like no longer relevant, then we'd love your contribution. Yeah, so that's like the cycle that we want to achieve with Radar. Yeah, so that's basically it. So again, my name is Tomer. I'm from AuditWare. My team is right here. We'd love to talk to you downstage. If anyone has any questions, free to speak up or talk later. That's it. Thank you so much, guys.